Dear students, today we are going to discuss maintenance management, block 3, analytical methods and models, unit 10, economic of repair and replacement of equipments. So before starting this particular sessions, first we have to understand the objective of today's sessions. So objective of today's session is student take the decisions of replacement. Student must understand how the replacement should be done in case of maintenance management, how the repair should be done in case of maintenance management, how the overall should be done in case of maintenance management. The next is student must understand the economic considerations of repair, replacement of the equipments. Then third objective we have appreciate the fundamental of replacement problems with regard to the unit, machines and the components. Then acquaint yourself with the mathematical model used for decision makings with regard to the replacement of capital equipments, unit machines and component and overall of the systems. Moving to next one, so these are the content of today's sessions. Introduction of that is known as replacement, repair, or overalls. So the next content we have that is known as preventive versus breakdown maintenance. Before implementing the replacement, repair, or overall, we have to understand what is preventive as well as the breakdown maintenance. Then present worth, interest formula, and equivalence with respect to the maintenance management. The next one we have the determination of optimal replacement intervals or economic life of the capital equipments. The next content we have that is known as evaluation of replacement alternative, defender versus challengers. Then we have to understand the basic of maintenance models. Then go for determination of unit machines and component with respect to mathematical model uh, in case of maintenance model. Then determinant of the optimal replacement interval for an equipment whose operating cost increase with the use. Then we have to go for the next content we have that is on a determinant of optimal replacement interval of a component's equipment subject to sudden failures. Then block replacement policies, which basically includes the determination of optimal interval between preventive replacement, then repair and overall decisions with reference to preventive and breakdown maintenance. The next content we have that is known as determination of optimal overalls interval for deteriorating equipments and optimal overall cost limit for the deteriorating equipments. So these are the content of today's sessions. Let's introduce or let focus upon the introduction part. So as far as concerned with the preventive maintenance program, which is basically prevent the inconvenience and high cost breakdowns by keeping the industrial plants, equipments, component is near new or as near as possible to the good as new conditions, not only through the routine of critical preventive maintenance, but also through the replacement inspections to certain the state of condition or the state of condition of equipments, which in terms may be followed by the certain corrective actions. So objective of this particular session is we have to understand what is the basic objective of replacement, how it should be inconvenienced with respect to the cost which is directly associated with various amount of breakdowns. The next important part is the inspection should be done for various kind of various stages of machines which is maybe new or maybe used as new conditions or it is not focused upon the routine or predictive maintenance. So as far as concerned with this introduction part, you have to go for the preventive maintenance, which is basically focused upon replacement policies of spare parts for a specific machines or machines units, and we have to conduct large amount of regular inspection of various equipment so that the lifespan of that machines or equipment should be provide higher amount of that productivities with reference to preventive maintenance. So let's take a case of that is known as spark plug, which is basically used in case of two-wheelers. And spark, the function of spark plug is that basically provide the ignitions or starting of ignitions inside the combustion chamber of the engines. So in case of new one, there is no certain amount of problem, but whenever you apply the preventive maintenance, in that cases, You have to regularly go for check up the distance between the teeth as well as the spark. So if you not maintain the proper that is known as distance or gap in between the spark and the top part of the lever, in that cases you can face large amount of breakdown with respect to starting of engines. So whenever you go for that is known as number of kilometer run after 2 years or after 3 years, you have to go for checking or done large amount of inspection, especially reference to the deposit of carbon on the that is on the thread part of spark plugs. So if required, we must go for replacement, and if not required in that cases, you have to apply the preventive maintenance so that you can clean the carbon deposit from the top layer of your that is known as thread, and similarly it increases the that is known as potential functionalities of the engines during the ignition stage. So that is why the corrective that is known as actions which may be include the adjustments, minor repair, preventive replacement of some component as required. So I have already given the example of spark plugs. If required, you must go for adjustment, that means tightening of spark plugs on the proper positions. And if required, minor that is known as repair should be done. That means you have to cleaning the carbon deposit on the upper part of spark plugs. And if required, must go for that is known as replacement of these parts. So if you observe the durabilities of your use in case of two-wheelers, it's depend upon the that is replacement policies for a specific part which is known as spark plugs. So during the inspection stage, you have to identify that is the different layer of carbon deposit on the upper surface of spark plugs, and by the inspections, you can easily identify and take the decision whether it should be go for minor repair or whether you go for a replacement policy for the spark plugs. So in that cases, the economic basis of these decisions will be discussed in details, and it also be illustrated through the real life examples. So I have already given the example of spark plugs, how the spark plugs should be include under the preventive maintenance to avoid such amount of breakdowns for the starting of engines or ignitions for the engines inside the combustion chambers. Moving to next one. So the next one we have to understand the fundamental concept of preventive maintenance and breakdown maintenance. So if we go to the fundamental definition of preventive maintenance, it identifies the potential issue before they become critical. So in the previous session or previous slide, we have discussed about the preventive maintenance which is applied for that is known as spark plug for a two-wheelers, and how the inspections or replacement or minor repair should be done by the help of preventive maintenance to avoid the criticalness in case of these kind of that is known as spare part which is used in case of motorcycles. Moving to next one, if you goes to the fundamental concept of continuous breakdown maintenance, it is initiated after the malfunction is identified. So breakdown means if you run your bicycle for a certain amount of period and during the ride, suddenly the engine is stopped. So then after you have to identify or inspection should be done to identify the type of breakdown or type of malfunctions. Then after you have to implement the breakdown. So same pattern should be observed in case of industries. So if you find the potential issue in a machines, in a gearbox, in a component, and by apply the preventive maintenance, you can easily eliminate the different kind of critical error from the systems. But in case of breakdowns, when the machine get malfunction, in that cases you have to immediately inform to the maintenance management departments, and then after they will reach to the particular spot to provide the adequate solution for the breakdowns. So these are the common difference between preventive maintenance and the breakdown maintenance. So if you go to the that is known as different aspect of preventive maintenance versus breakdown maintenance. So if you goes to the first one is the definite definitions. So regularly schedules maintenance activities to prevent the equipment failure is known as preventive maintenance. And in case of breakdown maintenance, maintenance performed after the equipment is failed. So if you goes to the preventive maintenance approach, they are proactives, and maintenance breakdown maintenance is reactives. So the next aspect we have that is known as cost. So higher upfront cost but lower long-term cost due to the fewer breakdowns. But in case of breakdown maintenance, lower upfront cost, but higher long-term cost due to the unplanned downtimes and the repairs. The next one is next aspect we have that is known as downtimes. So that means the plan and control during one peak times, and in case of breakdown maintenance, unplanned and upon peak during the peak times, leading to more significant disruption or that is known as error in case of productions. Then next aspect we have that is known as equipment line. So the preventive maintenance provide that is known as extended equipment's lifespan throughout the regular upkeeps, or that means checkings. But in case of breakdown maintenance, potential certain equipment lifespan due to lack of regular maintenance. Then the next aspect we have that is known as failures, lower as issue are addressed before the failure occurs. But in case of breakdown maintenance, the failure rate is very much higher and failure happen before the maintenance is performed. The next aspect we have that is known as spare parts inventories. So need maintaining an inventory or spare parts, but in case of breakdown maintenance may require immediate access to spare parts leading to potential delays. So if the spare parts is not readily available, in that cases, the maintenance should be go for large amount of lead time, which is provide potential delay in case of maintenance management. Then the last aspect we have that is known as impact on the operations, minimal impact or nominal impact or minimum impact as the maintenance is properly planned. But in case of breakdown maintenance, significant impact due to the unexpected downtimes. So these are the most important aspect of your preventive maintenance versus breakdown maintenance. I repeat, if you go to the fundamental aspect of your preventive versus maintenance, breakdown maintenance. So the regular scheduled maintenance is known as preventive maintenance before they provide the critical or error. But in case of your breakdown maintenance, it is initiated after the malfunction or you can simply say performed after the equipment is fails. This is the basic definitions. Moving to next one. So next one is preventive versus breakdown maintenance. So first one is what there are many kind of decision will be taken, especially reference to preventive as well as breakdown maintenance. So the first decision we have that is known as replacement decision. So whenever you think about the replacement decision, one most important parameter is considered in your mind that is known as cost. So to restrict the cost decisions, many companies go for minor repair or they provide the repair maintenance so that the lifespan of that particular machine or equipment should be extended. So if it goes to the replacement policy, form the integral part of all industrial maintenance program. But the thing is that here, whenever you think about the replacement policies, the cost consideration should be in your mind. So whenever you think about this cost of preventive replacement actions, it must be more costly to replacement equipment and components. So after failure than before. So whenever you think about the cost decisions, you must focus upon the replacement decisions, which basically includes the first important part is the state of equipment, whether good or fail, is always known with the certainties. The next decision we have a replacement action, return the equipment to as the new condition so that the new equipment or a component can continue to provide the same service as the equipment and component which is has replaced. And the third decision is operating or running and the maintenance cost of the equipment subject to replacement are increased or alternative or hazard date of equipment or the component must be increased. So these three decisions should be taken under the replacement policies. So first you have to understand the condition of the machines, that means it is good or fail. The second important part is the action return in case of replacement is whenever you apply these replacement actions to a specific machines, in that cases it should be provided like new conditions or continue as the same service provided by the previous equipments. So that decision will be taken by the that is known as maintenance manager. And the last and most important part, whenever you focus upon replacement decision, you must focus upon that is known as maintenance cost of that particular equipment, subject to that is known as replacement or increase, And the next is you have to focus upon alternative. The hazard rate of equipment or the component must be increased. So these three decisions basically made. But if you go for the other aspect of replacement decisions, you have to conduct replacement analysis fundamentals so that you can easily identify the condition of the machines. Then you must conduct the economic service life. That means if you provide the replacement, what is the service life or operating service life of that particular machines? Then the organization or department must go for replacement analysis when required the service for long period or long range activities. And the last one is the replacement analysis with the tax considerations. So if a company is invested large amount of money for spare parts, and in that cases they must consider the tax considerations with respect to replacement analysis. Then after they will take the replacement decisions whether they go for permanent replacement or may they go for minor that is known as adjustment of the machines, or in some cases they go for permanent replacement of the spare parts so that they will acted like a new conditions of the particular machines. Moving to next one. The next one is replacement of capital equipments. So here what will happen? You have to take the decisions to replace the expensive capital equipment involved the investment of large sum of monies. So for example, a company or a manufacturing company has number of CNC machines. So CNC stand for computer numerical control machines. So these machines are highly expensive capital equipment machines, which is used in case of precise component making. So before implementing the replacement capital equipment, you have to think about or take the decision about the highly expensive capital equipments. The next important part is the capital equipment has useful life of many financial years. So here you have to focus upon the cost such as running and maintenance cost, benefit occurring from the investment in form of revenue earned, or you can simply focus upon the return on investment of this capital equipments after certain amount of life of running. Then the next important part, you have to focus upon the product and service produced to continue for a number of years. So in this way, you have to take the decision. Moving to next one, let's take a small example. Since the money is on interest at a certain rate through its investment for a period of time, and it is important to recognize the sum of rupees 1000 received at the some future date is not worth as much 1000 in hand the present. So suppose a company invested 100 rupees for a spare part for expensive capital equipment, and after 10 years they can earn the same amount. So that is not a profitable, that is known as decisions for replacement of capital equipment. So that is why the relation between interest, the time leads to concept of time value of monies. So that is why whenever you think about the capital investment of equipment, in that cases you take large amount of decision with reference to the cost. The next is with reference to the benefits. The next the service, and the last important part is the lifespan of the machines, which basically enables productions of product. Moving to next ones. So how to calculate this present with interest formulas and equivalence of the highly capital equipments. So let's take the example of that is known as this mathematical expressions for present worth calculation for replacements. So P stand for principal amount, N stand for number of years or the number of annual interest period for which it has been invested or borrowed. I stand for annual interest rate in percent. So whenever you go for the interest earned by the investors or due from the borrower, that is P and I divided by 100. So P stand for principal, N stand for number of year, I stand for annual interest divided by 100. So if you convert these equations, the total sum due to the principal plus the interest, and that is the F, or that is known as the sum resulting from the initial investment equals to P. Again, P stand for principal amount plus P and I divided by 100. Or if you go for simplification of this equation 1, that is P into 1 plus 1 divided by 100 into N. So this is equation 1 to go for calculating the initial investment equations. The next one is if the principal amount is interested for an annual interest period and the relevant interest rate is that is known as 1% per annum. The payable annual is then the n years the sum of f, that is the principal plus the interest resulting from the interval or initial investment, which is expressed as the mathematical formulation, that is f equals to p into 1 plus I divided by 100 to the power n. So this is the equation that is known as 2, where the present value and the present worth of the sum of money to be spent or received in future is obtained by the doing the reverse calculations. Thus, the present worth of function f, or that equals to the principal amount equals to f into 1 divided by 1 plus I divided by 100 to the power n. So this is equation 3 for calculation of present worth and the interest formulas and equivalence. Then if the interest rate of I% per annum is paid m times per year, then the n years of the value of that is known as present worth of an initial investment, that is P, that should be expressed in mathematical way, that is F equals to 1, so the P stand for principal amount into 1 plus I divided by 100 divided by m to the power n into m. So here n is the number of year and m is the that is known as time per year should be calculated. So in this way, by the help of this is equation 1, equation 2, equation 3 and equation 4, you can easily calculate the present worth and interest rate formulas or rate of interest which is applicable on the period of time, that is known as m, and number of year, that is known as n. Moving to next one. The next formula we have, let's the present value of principal amount of the money to be spent on receipt n years in the future. The formula should be expressed, that is P equals to F into 1 divided by 1 plus I divided by 100 and total divided by m to the power n into m. Similarly, if you go for the next formula, it is possible to assume that the interest rate is paid continuously, and this is equivalent to letting m in equation 4 tends to infinite. When this is the case, the appropriate present worth formula can be expressed as that is known as P equals to function of exponential minus I into n divided by 100. So moreover, if you goes to further equating the equation 3 and equation 7, it should be expressed as the principal amount equals to that is known as present worth exponential of minus I interest rate and n stand for number of year. So this is the formulas that basically used to calculate the present worth, rate of interest and number of years. So whenever you think about to go for replace or implementation of replacement policies for highly expensive machines or equipment, in that cases you have to use this formula or mathematical expressions to go for calculation of that is known as principal amount by the help of present worth, rate of interest and number of years. Moving to next one. So let's take a small examples which consist of three number of machines tool, that is A, B and C, and their purchase price is given 5 lakhs, 3 lakhs and 6 lakhs respectively. The installation and commissioning costs are given 10,000 for machines tool A and installation costs 10,000 for machines tool B and installation cost and commissioning cost for machine tool C, that is 10,000. So total cost of acquisitions are 5 lakhs 10,000 rupees for machines tool A. Similarly, total cost of acquisitions for machine tool is 3 lakhs 10,000. Similarly, in case of machine tool C, the total cost of acquisition is 6 lakhs 10,000 rupees. So whenever you go for operating and maintenance cost for first years, that is 10,000 for machine A, second year same amount 10,000, third year same amount 10,000. Similarly, if you go for the machines tool B, the first year is 20,000, second year 30,000, third year 40,000. The next is in case of machine tool C, the operating and maintenance cost is 5,000, 8,000 and 10,000 for year 3. The next is the slavage, that means for machines tool, that is 30,000, or the sum of this operating cost and maintenance cost is known as slavage. Uh, Cost, that means slavage. The next is for machines tool, that is 15,000, and for machines, that is known as C, it is 35,000. So in this particular problem statements, we have to calculate the present worth of three investment alternatives like A, B, and C machines tool to be able to compare them and arrive at the choice which is achieved optimum economy in terms of monies. And let's assume that the discount rate R equals to 0.9 and rate of interest I equals to 11%. So let's calculate for the present worth of machines tool. A equals to, we have the total cost plus your first year cost into 0. Right, it's discount rate, then 10,000 into 0.9 square, then 10,000 again 0.93 skew, and last one is 30,000 into 0.9, that is the rate of discount rate with our Qs, and that equals to 5,12,520 rupees. Similarly, we have go for calculation of present value for the machine to B. The capital cost is given 3,10,000 plus 20,000 into 0.9 Q plus, sorry, it is wrong, it is 0.9 only, plus 30,000 into 0.9 square, then 40,000 into 0.9 Qs minus, that is 15,000 into 0.9 Q, that equals to 3,70,520 rupees. Similarly, if you go for calculation of the present worth of machines tool C, so we have total cost of acquisition is 6,10,000 plus 5,000 into 0.9, that is the rate of discount rate is given. Similarly, the next year, second year, 8,000 into 0.9 square, and similarly for third year, that is 10,000 into 0.9 Qs minus 35,000 into 0.9 Q, that equals to 6,02,755 rupees. So from comparing the machine tool A, machine tool B, and machine tool C, we find that so the machine to B has, that is known as minimum present value of the cost, that is 3,70,525 rupees as compared to machine tool A and as compared to machine tool C. So machine to B should be purchased since it's given the minimum present value of the cost. So in this way, they can basically go for the replacement policies, which is very, very important on the aspect of cost. And by using the present values, interest, and the calculation, we can easily identify which machine tool is most important for purchase and what is the present value cost of that particular machines. Moving to next ones. Here I have already given another examples with respect to the determination of optimal replacement interval or the economic life of capital equipments. So let's understand from this particular aspect of numerical. So we have n practices. The maintenance cost of capital equipment are generally increased with the age. So as far as concerned with the practical use of machines, when the machine is used more than the first year, second year, third year, up to 10 years, automatically the equipment cost is increased with the age. And with respect to maintenance, the cost is directly linearly increased annual maintenance cost. So I have given an example of annual maintenance cost, which is linearly increased function of times with the increase of age. So for example, we have end of year, that is known as number of years given starting from 1, 2, 3, 4, 5, 6, 7. The salvage values are given like 2 lakhs, 1 lakhs 50,000, 1 lakhs again 80, 70, 60, 50. And the next is ESC of the capital recovery and returns. So in case of first years, we have 3 lakh 30,000. In the second year, we have that is known as 1 lakhs 99. Then 99,904. In the next year, we have 1 lakhs 55,644. Similarly, in the fourth year, we have 1 lakhs 26,000. Again, in the fifth year, we have 1 lakh 6,000. Then in the sixth year, we have that is known as 93,000. And 7th year, we have that is known as 83,000. In the eighth year, we have 80,000. And the maintenance cost is also in the initial year, the equipment maintenance cost involved 10,000, and it will be increased up to the 80,000 for the year, that for 8 years. So the next important part is that you have to also focus upon the present worth fact, or that is known as present worth of the machines. That means 0.9 if you go for calculations. That means P divided by F. So P divided by F means that is known as your principal amount divided by the present worth, that is 0.9. And similarly, if you calculate in case of the last 8 years, the principal amount divided by present worth is 0.6. The next important part is present worth maintenance of beginning year 1. So that first year we have provided the present worth that is known as 9,000. And if you observe in case of 8 year, it should be surpassed more than 50,000. Then if you go for cumulative, that is known as present worth of the maintenance, it should be surpassed more than 2 lakhs 60 rupees. And if you go for capital recovery factors, that is annual annual income divided by the factors into 6 into number of years, in that cases it also increase up to 0.161. And if you go for that is known as economic life of capital equipments maintenance cost, that surpass more than 41,000 as compared to the first years. And if you go for the total cost, that means it surpassed starting from the 1 lakhs 22,000 as compared to the first, that is 3 lakhs 40,000. So if you go for the non-linear form of maintenance cost instead of price-wise linear form, it will be obviously result in the smaller minimum cost line and shorter optimal replacement intervals. So whenever you go for optimal replacement interval, in that cases you have to focus upon the economic life of capital equipment calculation before go for that is known as implementing the replacement policies. So here the most important part is you have to think about the age factor of the machines. The next important part, the annual maintenance cost should be keep in your mind, so that whenever you go for these kind of calculations, in that cases you can easily identify the linear continuous graph of the maintenance cost. So moving to next one, the next one is evaluations or replacement alternative, which basically provide the defender versus the challengers. So in this particular segment, we'll going to discuss about what are the challenges and what are the defending factor which is considered in case of replacement alternatives. So the first important objective of that is known as the future cost of ownership of different assets, which basically demands that replacement of an existing capital equipment with the possibles or modern equipment having lower operating and the maintenance cost. So whenever you think about the economical aspect of replacement strategies, in that cases you have to focus upon the lowering the operating cost as well as the lowering the maintenance cost, so that you can easily take any kind of replacement policies with respect to maintenance management. So as far as concerned with the replacement studies, there are two assets are compared. The namely, first one is that is known as defender, and the second one is its challenges. So since the economy of future of challenges can also be represented in the same way, the method of analysis used earlier can be used to compare the cash flow of the defenders. So it are these two factors like defender and challenger are the two assets of the replacement studies. So let's understand from the economic decisions problem, which is must taken into account. First one, the challenger will have high capital cost, lower operatings, and lower maintenance cost. With the reverse is true for the defender. That means that is known as low capital cost, high operating, and that is known as high maintenance cost. So in case of defender, which is the equipment being considered for retirements? The capital cost of defender should be lower, decrease, while it's operating the maintenance cost should be higher and increasing. So challenger basically focus upon higher capital or higher expensive that is known as equipment cost. They can go for that is known as decrease the operating and as well as maintenance cost. But in case of defender, they must focus and consider which equipment should be retired, and they basically decrease the operating and maintenance cost, and the maintenance and the operating cost should be higher or increasing depending upon the aging factor of the machine and equipment. The next is point number two. The remaining life of Defender is usually short, and the future operating and maintenance cost can be estimated with the relative certainties. So a clear superiority of the Challenger is not brought out by the analysis. So it is advisable to the defender the replacement decisions and review its year later. So from the initial days, defender should not be implemented in the form of assets with reference to the replacement policies. But the thing that when the aging factor is applied to the machines and component, in that cases you can also take the replacement decision by the help of defenders. Moving to next one. So the next point we have, that is because of tax implications associated with the retirement and depreciation of physical asset, the effect of taxes on various replacement alternative can sometimes be significant. So whenever you think about the taxes, the effect of taxes on replacement decision does not in any way affect the method of comparing the replacement alternatives, whether you go for the challenges or maybe defenders. And in case of engineering economics, the replacement decisions, the role of sunk cost must be considered or that must be understood and treated correctly. So here, if you go to the fundamental definition of sunk costs, this is the difference between the present book value of the asset and present realizable salvage value. That means the market value if the existing asset is sold now. So if incorrect estimate, the market value the defender are made, and there is always the danger of ending of the positive sunk cost, which cannot be recovered. And for this reason, some analysts recommend the sunk cost of defender can be recovered by the adding the cost of acquisitions of the challenges. So if you go to these two factors, especially reference to evaluation of replacement alternative, that means we have two number of assets. One asset is that is known as challenger, another asset is defender. So let's understand the fundamental of this evaluation of replacement by the help of these two assets. So the first asset is that is known as challengers. So challenger is basically focused upon high capital cost, lower operating cost and maintenance cost. But defender basically focus upon the equipment who are basically considered for the retirement of the machines or equipment, and defender basically focus upon the known as that is decrease or lowering the operating and maintenance cost. If required, they may go for hiring or increase the operating and maintenance cost. This is one aspect. The next important part is if you go for defender point of views, in that cases they usually short and the future operating and maintenance costs can be estimated related to the certainties. But in case of challengers, they brought out by the analysis, which is advisable to the defender by taking the replacement decisions. Moving to next one, if you go to the third important point, most of the cases, whenever you think about the capital investment of the machines or capital investment of equipment, the tax consideration is most important part for physical assets, especially reference to those who are under the retirement or who are going to be take the various replacement alternatives. So here the taxes basically affect the replacement decision. This is the third point. And the fourth point is you have to focus upon engineering economic analysis. So in case of engineering economic analysis, first you have to understand the sunk cost. So what do you mean by sunk cost? Sunk cost is basically focused upon the book value of asset, and it basically go for the present that is known as market values of existing product which is going to be sold or what is going to be sold in the present days. That is known as salvage values. So the sunk cost is the difference between your book value versus your salvage values. So you take the positive decision whenever you think about the sunk cost by the help of defender. You can easily go for anticipation or adding the cost acquisition of the challenges. So this is point number 4. By the help of economic analysis, you have to understand the sunk cost, which is consists or which is maybe the difference between your book value cost and the next important part is their salvage value, or that is known as market value, if the existing asset is sold in present scenarios. Moving to next ones. The next one is basic maintenance models. So the first model we have that is known as replacement models. So in classic total replacement model, we basically assume that the equipment is always replaced completely. The replacement is done continuously or instantaneously. That is consumes no times. The equipment failure is detected as soon as failure takes place. So before any kind of failure takes place, you must go for replacement. That is the condition of replacement models. So here we have two number of replacement options. The first one is preventive replacement, which is shortly known as PR. And under the preventive replacement, following the predetermined preventive maintenance policies. So that means it should be implemented on the basis of the condition of the machines. The next important part is if required, you must go for immediate replacements. The next one we have, or next option we have, that is known as corrective replacement, which is shortly known as CL. So they are basically following the equipment failures. When equipment failures occur, immediately we have to provide the maintenance policy. So these are the two basic options for the replacement models. If you go for further, that is known as extension of this total replacement models, which basically consider the following preventive replacement policies. The first one is constant interval replacement. This is known as CIR, or shortly it is known as CIR. So this replacement is done after the certain constant time interval. This is the first policies. And the second one is age-based replacement, which is shortly known as ABR. So ABR replacement is done when the replacement reaches the certain operating time or ages. So for example, you are using the pump and the durability of pump should be lasted 15 years as per the company has given the recommendations. So if the pump is already reached to that particular age, depending upon the age, you have to apply the age-based replacements. So there is no need to go for any kind of adjustment, any kind of minor repair should be done. You can directly implement the policies like the age-based replacement. But in case of constant interval replacement, for example, bearings. So in case of bearings, the company has given the recommendation that bearing life should be lasted for 5 years. So before you reach that particular 5 year, depending upon the constant intervals, that means within the span of 2 to 3 years, you have to replace this particular bearings as early as possible. So these policies basically known as constant interval replacements to avoid large amount of equipment failures. Moving to next one, how this constant interval replacement is implemented. The lifespan is given in the form of mathematical formulas. So here what will happen, the replacement are done after the failure, it is known as failure rate, or after the certain constant time interval, that is TP. So this model is developed, and this model is developed to calculate or determine the optimal time interval between the two prevent replacement, and the optimization criteria are to be minimized so that the total expected cost per unit time should be reduced. So here in this particular model, a linear line is drawn and t equals to 0. This is the initial point or initiation of the that is known as machine or installation of machines. Then CRs stand for that is known as your failure rate. The next is PR means your that is known as interval times, and in between the PR and PR you can find a TP. So TP is the constant time intervals. So within the implementation of failure, number of failure in between the that is known as time interval, you have to choose the constant time interval to replace the item, so that you can directly optimize the total cost per unit times, and the machines or equipment should be available for operating conditions. So if you go for the details of this particular models, that CP is equal to the PR unit cost and CC is the CR unit cost, TP is the PR times, and FT function of T is the time to failure probability distribution. Again, the time to failure probability density function, that is N into TP, and expected number of failure is equal to 10 within the time interval 0 to TP, and TCTP total expected cost per units are given. So these are the different notation given to the replacement models. So if you go for that is known as mathematical formulation for total expected cost per unit time, which is known as TEC-TP, that equals to TEC starting from 0 to TP divided by length of your that is known as constant time interval, that is 0 to TP, that equals to CP. CP stand for your PR unit cost plus CC into N into TP whole divided by TP. So here N stand for your number of there is expected number of failures, that is 10 within the interval times, and again the N into TP stand for, as I told, that is known as expected number of failures, and again TP stand for that is known as your constant time intervals. So by using this particular mathematical model, you can easily calculate the constant interval replacement, which is shortly known as CIR. So if follow these policies, the number of failure is appreciable, and it notice that many preventive replacement could be done when the operating time of the equipment is below the constant interval, that is shortly known as TP. So which of the costs could make this policy less efficient? So this is the entire mathematical model and the mathematical expression for calculating the constant interval replacements. Moving to next ones. The next one is age-based replacement. As I already given the example of the pump, how the company has recommended the age of this particular pump is lasted for 50 years. So if it is near approximately near the 15 years, you have to apply the age-based replacement for certain amount of that is known as equipments, and as well as that is known as machines or equipments. So here the PR or that is known as replacement is done after the equipment reaches certain operating time age, which is denoted as TP. And in case of equipment failure, that is known as CR is done, and the next replacement is scheduled after the time and age of the unit. And we again want to calculate the best time interval or certain operating times which minimize the that is known as total cost per units. So if you go for the mathematical model, the same mathematical model is there, but you have to think about the operating time as well as the age, so that you can easily apply the age-based replacement. So here the mathematical model for that is age-based replacement, that is known as TEC, TP equals to CP into R into TP plus CC F into TP, and again whole divided by TP R into TP plus M into TP into function of TPs. So here optimum TEC TP will be obtained by the minimized equations, that is with respect to the certain operating time and age, which is denoted as TPs. So by the help of this linear mathematical models as well as the mathematical expression, we can easily calculate the total expected life of this particular machines, and how the age-based replacement will be conducted when the machines or equipment reaches to the certain operating time or age. Moving to next ones. Next one is replacement of units and machine components. So here what will happen? Let's before starting this particular slide, we will take an example of the different component of your CPUs of a desktop computers. So these are the different elements of the central processing units. So that means power supplies. We have graphics card and AGVs buses. We have PCI buses. We have motherboards. We have CPU cooled by the computer fans. We have CD and DVD drive. We have hard disks, and last we have covers. So whenever you apply the replacement unit of machines and component, first you have to focus upon the machine and components. Therefore, they can be classified either deterministic level, in which the time of equipment replacement, which in terms is dedicated by increase the tens of operating and maintenance cost. So for example, if you want to go for replacement of motherboard, so in that cases, first you have to identify whether the motherboard condition is good or it should be replaceable. Similarly, if you go for CD and DVD drives, so whenever you go for increase the operating cost or operating that is known as hours, so that operating hour is basically provide the various aspect of maintenance and maintenance cost. So in which the timing and outcomes of the replacement action depends upon the chance, and since it is generally very difficult to predict with the certainty when the failure of component will occur. So we never know the certainty of failure in case of CPUs. For example, there may be some power supply disruptions should be there. Maybe the cooling fans or computer fans should be jammed, or maybe there is some technical glitches happen in case of PCI buses or in case of graphics cards. We cannot predict this particular certainties of failures. So when failure will be occur, then after we will provide the replacements. So this is the typical example of CPUs, specially reference to desktop computers. Moving to next one. The next one is determination of optimal replacement for an equipment whose operating costs are increased with the use. So let's consider an equipment which is not subject to sudden failure, but whose deterioration through use result increase operating and maintenance cost. So let's take the example of a gearbox. During the initial use, there is no chances of failure, but whenever you go increase the operating uh, number of hour or thousand number of hours, in that cases it increase the maintenance cost. So to reduce the operating and maintenance cost, the replacement can be performed, and here we are basically done the replacement and the trend of operating cost is known. So thus, whenever you focus upon the operating cost trend, following each replacement are identical. And the next important part is you have to focus upon the interval between the replacement is constant and of length. So in every 2 years, by annually, major survey are performed on equipment as per the statutory requirements by the maintenance management department by taking the prior approval from the top level of management. So it is the duty of maintenance manager who provide routine basis survey perform on various equipment as per the statutory requirements. So between the two consecutive survey, the operating cost and the equipment increases due to the deterioration of the certain parts of equipment. So that part should be replacement. And how about the replacement cost money in terms of materials, in cost of that is known as labor cost or labor wages, the cost of spare parts, cost of manpower, and thus balance the stock between the money and the spend of replacement. So these things should be considered whenever you go for the optimal replacement interval for equipments. Moving to next one. The next one is the determination of optimal replacement interval for component or equipment subject to sudden failures. So in case of sudden failures, in that cases, because most of the cases it happened to the valves, gearboxes, pumps, chemical metering pumps, electronics control devices. So you cannot predict the that is known as failure rates. It suddenly fails. So due to the fall in category, the item which work perfectly satisfactory till they fail. There is no age related to increase the operating and maintenance cost. So yeah, I have already given the example of gearboxes, already given the example of water pump. So in that cases, or chemical metering pump or electronics control devices, you cannot take the that is known as age-based replacement in this particular cases, because when they reach up to perfectly satisfactory levels, in that cases it should good. But when they fail, in that cases, though no age consideration should be done. So with related to increase the operating and maintenance cost, we'll focus upon the following procedures. The first procedure we have constant interval policies in which the preventive replacement of the equipment is carried out at a fixed interval. I repeat, the constant interval policies. That means in which the preventive replacement of the equipment is carried out at fixed interval. The second one is the problem is to determine the optimal interval between replacement to minimize the total expected cost for unit time, and the age was policies where instead of preventive replacement at a fixed interval or one determine the optimal replacement age of the items. So the first procedure is known as block replacement policies, and the second procedure is known as this is age replacement policies. I repeat, in case of block replacement policies, we are using constant interval policies. In case of age replacement policies, we are minimize the expected total cost per unit depending upon the age of the equipments. So moving to next ones. So block replacement policies, which is apply for determination of optimal interval between preventive replacement. So how this preventive replacement should be done? The first important part is the equipment or the component is subject to sudden failures. When the failure occurs, is to be replaced. So in that cases, this is true in most cases because preventive replacement can be adequately planned and necessary arrangements made for it to reduce the time and the cost, especially related to operating time and maintenance cost. And there may be a possibility that the failure may cause damage to the other component of an equipment. Suppose you have parallel series of equipments are there, or that is known as continuous series of equipments are there. If one equipment is failed, it directly have affect the entire flow of material or number of workstations. So in that cases, making total replacement costs much greater after the failures. So to determine the optimal interval between the preventive replacement to minimize the total expected cost of replacement per unit times, given that the CP or that is known as CP, the cost of preventive replacement, and CF is known as the cost of failures, and CF is always greater than your CPs, and TP the time interval or fixed time interval between the preventive replacement. Then the total expected cost per unit for one cycle uh, equals to that is CP of TP, total expected cost in interval divided by length of the intervals. So in this way, we have to calculate the total expected cost. So that equals to the cost of preventive replacement in interval plus expected cost of failure replacement. That equals to CP plus CF into H into TP. So here HTP is the expected number of failure intervals, and if you go for further calculations in the form of mathematical expression, that is CTP equals to CP plus CF into HTP divided by TP. So the problems comes down in case of determination of that is known as expected number of failure of intervals. In case of FT, the failure density function is known and the expected failure over the large interval, that is ST, can be obtained from the expected mean life or the mean time to failure, that is given the time to failure can be written by the negative exponentials, which is known as Weibull or gamma distribution with the known parameters. So this is the Weibull and gamma distribution mathematical model which is applied for the block replacement policies to identify the optimal interval between preventive replacements. Moving to next ones. The next one is repair and overall decisions. So in case of overall action is taken to restore the entire equipment to satisfactory working conditions or nearly as possible to the as good as new condition, so that you have to minimize the incident or unexpected failures. But it is carried out before the equipment and system reach defined failed states. So let's take an example of power plant, which consists of number of departments, number of divisions. The first division we have that is known as we have boilers. Boiler generates steam. Steams are goes to turbine. Turbine is connected to that is known as transformer. Transformer is generate the electricities. And in case of that is known as steams, we are using condensers, which basically cool the hot water from the boiler to the river bank, and again the water is recirculated to boiler. So it is a continuous process. But in case of continuous process, what first important part is you have to go for the expensive equipments or sophisticated equipments like boiler are required to be overhauled at the present interval as per the statutory regulations. So boiler inspector are basically assigned in case of power plant. They are take care about the boiler, and in the regular interval they must provide the that is known as overhauling the that is known decisions regarding the boilers. The next important part, the decision to the overhaul of an equipment may be taken when the equipment operating and maintenance cost is found to be increased. So if you're not taking any kind of regular overall decision process, the maintenance cost is automatically increased. So that is why if you take other industries like small scale industries, medium scale industry, large scale industries, those who have precise part or those consist of some complex part, to increase the that is known as operating time as well as decrease the maintenance cost, the overall decision should be taken. The next important part is that if you take the cases of power plant, in that cases the estimated overall cost is compared with the overall cost limit, and if less than the overall cost limit, it is overall otherwise replaced with the new equipments. So if you go for regular interval of overall decision with respect to boilers, in that cases if you find any kind of difficulties, you can simply replace the entire boiler which is generate the steams and which do not affect the power generation in case of captive power plants. Moving to next one. The next one is determinations of optimal overall interval for deteriorating the equipments. So before elaborating those things, this particular slide is directly deal with the optimal overall interval for deterioration of equipments. So let's take the example of the motorbikes maintenance checklist. So the first we have go for change the oils. The next is we have to go for replacement of air filters. Then change the coolant in case of engines, check the pressure and tire threads, check the tire threads in case of if required go for replacement. The next important part is clean the chains, then check the battery levels, then maintain the brakes, then clean the external bodies, and finally go for conclusion. So from that conclusions, with respect to number of years, number of kilometers, number of miles, there is certain amount of overhauling activity should be done so that you can easily minimize the maintenance cost with reference to the overall interval of the deteriorate equipments. So the next important part is the equipment of the system deteriorates with the use of or affecting the system, which directly affecting the operating cost of the bikes as well as the operating efficiency of the bikes. So that is why I have given some example of motorbike. First one is inspection the checklist, perform all item, then engine oil change, then engine oil filter element should be changed, then internal and exhaust valve should be cleaned, then spark plug should be inspected. If required, must go for replacement. Then air filter to be checked. If required, must go for replacement. Then brake fluid should be checked. If required, it should be replaced. Then rear wheel cross rubber should be checked for braking systems. If required, it must go for replacement. And finally, the frog oil or shock absorber oil, you have to go for inspection. If required, must be changed. But as far as concerned with the companies that is known as specifications, the engine oil should be rapidly changed after 2000. Similarly, if you go for that is known as engine oil filters, must be changed after certain amount of years. In case of tire or that is known as rubber, pad should be changed after running of more than 1000 kilometers. So these checklists are basically given for the deteriorations of optimal overall interval for the deterioration of equipments. Moving to next one. The next topics we have determination of optimal overall cost limit for deteriorate equipments. So let's take the same example of automobiles of a car. So the most important and most expensive equipments or that is known as component of car is that is known as engines. So here what will happen? First we must go for taking the estimation of cost of overhaulings of vehicles. The next important part is we will go for it as function of age and decision whether the overall and replacement should be done. Thank you.